Good morning everybody, and once again welcome back to the channel. In this particular video I do want to talk about breaking through Python GIL, that is global interpreter log, scaling multi-tenant S3 archival from hours to minute. So let me share a Medium blog that I very recently wrote, probably about 2 weeks back on July 19. So let me walk you over the use case, right? Again, this is a very simple sample mock data that I have. You have raw data, and of course you have some tenants. These are only like 4 or 5. Now imagine you have thousands and thousands of tenants, and each thousands of tenant is sending millions and millions of files. Now, of course, you have a processing system that's processing this data, of course, and once these files are processed, they are marked that, okay, I have processed this file, and now you need to archive these files. Archiving basically means that you want to copy the source file, this file right here, from here into an archive directory where the file stays for 30 days and then it moves into a cheaper storage tier, right? You want to move the files, right? So that's what archiving means. So in this video I want to talk about how we went from hours to minutes, right? So if you have one job and you do threading, right, you'll say, okay, you know what, for each tenant I'll do a list all the keys, and then for whatever keys there are, whatever files there are processed, I'll move them into the archive directory. I'll do a copy command and then delete command. These are the two commands that you do, right? Copy will basically move the object from source to destination, and then you delete the source file, right? Now that approach did not scale well, right? It took hours, 5 hours, 6 hours, and so on, right? So then how do you approach this, right? So let me share a very interesting approach here. Hopefully you find this insightful. It's the more details are on my Medium blog. So you have all these tenants, right? Tenant 1, tenant 2, tenant 3, so on, and thousands of tenants. Each tenant sending 100,000 and millions of files, right? Now you need an archival job, which will, of course, whatever files are marked process, you want to archive them, right? So how would you do this? Is basically you use a hash function, divide the tenants into buckets or bins, right, equally. So for example, you can see the bucket size k, right? So this particular bucket will have tenant 1 to 5, right? Simple, right? And so on. So basically spread the tenants evenly into buckets, and then each bucket becomes a Python job, right? So let me slow down. Each bucket becomes a Python job, and again each bucket does its own threading, and you can even spread this into multiple machines you want, right? So so for example, if I have my probably somewhere here, yeah. So think of something like this, right? Once you have the job in the queue, then you can route that particular site archiving into a machine. So for example, this, so let's say hypothetical, right? Bucket A, right? So bucket or bucket 1, let's write, or bin 1, whatever you like to say, bin 1. This will come here. Oh, okay. Go to machine this. Go to machine this. You go to machine this, right? So basically you'll distribute the job, right? So hopefully made sense, right? So let me show you a very simple demo, right? Like I think I have a simple EC2 machine spun up. Again, you can have 10, 20, 30 EC2 machines, however you want to add, right? So, but again, I'm just showing you the concept over here, right? So let's copy the job, and if you go to S3 here in the main bucket, you can see we have raw and we have some multiple tenants here, right? So now if I come to S3 and if I come to my terminal and submit the job via SSM agent, I can see I got the job ID, and I can also query that job. I can store this in some sort of a metadata over here, and if I just query that, you will see it's completed, right? So you can see completed. Now if I go back to S3, I refresh, tenant A is gone, as you can see, right? So if you see, tenant A was archived, all the files are archived. So see, what I'm saying is, right, with this approach, instead of having one job and then doing threading, divide the tenants into bins, spread it out, and then each bin can have multiple tenants depending upon what the batch size is, and then you can really fan out into multiple machines, right? So each bin can run on a different machine or the same machine, depending upon how you configure the logic, right? So hopefully you got the idea, right? And then you can add as many nodes as you want, right? 1, 2, 3, 4, 5, 6, right? And then you can use consistent hashings, and then each job you can route it to machine 1, machine 2, machine 3, and so on. So yeah, this is there on my Medium. Of course, first of all, thank you for all the audience for reading this blog. I'm glad you found it insightful. So the approach is mentioned on this blog. So let me know if you have any other questions. So yeah, I think hopefully you learned something new here, right? I hopefully you learned how to submit jobs to the EC2 machine via SSM agent, right? With that being said, if you have any other questions, let me know. Until then, keep smiling, keep programming, and I'll see you next time.